So here we're going to solve this Fourier series problem. Here we have a square wave question. So the signal here is a square wave. And we have been asked to find the expansion for this square wave in Fourier series format. Specifically, we're going to use the trigonometric format. Okay. So let me just write here using the trigonometric approach. Okay, so now the first thing to do is to find the period of the waveform. So the period is the time it takes for the waveform to repeat itself. So from here to here, minus 3 pi to minus 2 pi, it is not repeating itself. Minus 2 pi to minus pi is not repeating itself. Okay, it is only repeating itself at minus 3 pi to minus pi, minus pi to pi, pi to 3 pi. That's when it is repeating itself. So I'll take 0 to 2 pi as my period when it is repeating itself. Okay, so that is within here and here. So here t is equals to 2 pi. All right, so let me write here t is equals to 2 pi. Okay, and omega naught is equals to 2 pi on 2 pi, which is equals to t, since omega naught is equals to 2 pi on t. All right, so now from here we also note a certain characteristic of the signal. This signal is called a half-wave symmetry signal. It obeys the half-wave property. So this is the half-wave property. So the half-wave property is such that f of t plus or minus t over 2 is equals to minus f of t. So now, this property, basically what it says is that when half of the period, when it's half, my period is from 0 to 2 pi. So half of 0 to 2 pi is what? 0 to pi. Is equals to what? The negative half. So you can see that 0 to 2 pi is equals to what? The negative what? Half. This part is equals to what? This part. So this is the what? The half-wave symmetry. And this signal actually obeys that particular property. Okay? Because here and here are the same. Alright? So any signal that obeys the half-wave property will have odd harmonics. Half-wave property introduces odd harmonics. Okay, it introduces odd harmonics. If it's odd harmonics, that means that it will have what? Sine waves. So in this case, the cosine waves aspect will be 0. And the cosine wave aspect is what? Is an. So in this case, an will be what? 0. Okay, so here I will say that an, therefore an is equals to 0 for this signal. Now let me put down the entire formula or equation for finding the Fourier series in this trigonometric approach. So f of t is equals to what? A naught plus summation up to infinity, n is equals to 1, an cos n omega naught t plus bn sin n omega naught t. But here we are saying that an is actually 0. So here f of t is equals to a naught plus summation up to infinity from 1. This place is 0. And we know that omega naught is 1. So I'll have what? Bn sin nt. Actually, in this particular signal, if you watch, you see that this positive half is equal to this negative half. This negative half is equal to this positive half. So basically, it will be a naught to be 0. But let me prove to you why a naught is 0. Because if I just say it, you might not believe me, or you might not understand me. So now here, A naught is equals to 1 over t into t naught plus t into t naught into f of t dt, which is equals to 1 over 2 pi, because my period is 2 pi, into what? Please, here is what? A, and here is minus A, right? Okay, so let's continue from here. So it's equals to, here, what I have is that, you see the positive half is 0 to pi, and the negative half is what? Pi to what? 2 pi. So I'll divide my f of t into these respective what? Components. So here I can have, first let me just even write 0 to 2 pi into what? F of what? T dt. So I'll have A naught is equals to 1 over 2 pi into 0 to what? Pi, which is the positive half, into what? A dt. I'm putting negative here because this part is what? Negative. This part is positive. This part is what? Negative. So that is why I'm putting negative here. Into what? 1 over 2 pi into what? Pi into what? 2 pi into what? A what? dt, which is equals to 1 over what? 2 pi into what? Let me make here what? A, okay, into what? 0 what? To pi, okay, d what? dt, okay, minus A to what? 2 pi into what? Pi to what? 2 pi d what? dt. So here I'll just integrate from here. So now here A naught is equals to A over what? 2 pi into what? If you integrate 1, you get what? T. Okay. I can take A to 2 pi out because it's common. Okay. Into here 0 to what? Pi minus what? Another t. Okay. Into what? Pi to what? 2 pi. Okay. Alright. So here A naught is equals to A over what? 2 pi into pi minus what? 0 minus what? 2 pi minus what? Pi. Okay, so basically what you're going to have is that you're going to have A over 2 pi, A over 2 pi into pi minus pi. Okay, so that's what you're going to have. Okay, so here will become 0. If here becomes 0, the whole thing will become what? 0, which is equal to what? 0. So that's what I was telling you, that, see, this part is equal to this part, 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 this part is equal to this part. So they cancel out and it becomes what? 0. So the average value, or the DC component of this signal, is what? 0. Okay, as I have gotten here. So now that we know this one, let's proceed to what? AN. AN we know is already what? 0. So we wouldn't have to proceed to AN. Rather, let us proceed to what? BN. So let's see how we do with BN. So we know that BN is equals to 2 over what? T into what? T naught into T naught plus what? T into what? F of what? T sine n what? Omega naught what? T, which is equals to 2 over what? The period, which is what? 2 pi into what? Into here we have what? 0, and then what? To 2 pi into what? F of what? T sine what? N. Omega naught is what? 1. So n what? T dt. Okay, so that is what we have here. Alright, so now from here, say that Bn is equals to 1 over pi into 0 to pi, okay, into what? A sine what? Sine t, sine nt, okay, dt, minus what? Pi to what? 2 pi, okay, please, here it has to be what? 1 over what? Pi, okay, into sine n, E should be here, sine n t dt, okay. So what are we going to have? So we're going to have Bn is equals to A over what? Pi into what? 0 and then pi into sine nt dt minus A over what? Pi into pi and then what? 2 pi sine n t dt. Alright, so this is what you're going to have here. So now from here, I can just bring, go straight ahead and then do my integration. A pi into minus cos nt minus cos nt. There will be no dt here because I've already integrated. Okay, minus A over what? Pi into minus cos nt minus cos nt. Okay, all right, so here is what? Is here I have 0 to pi. I have pi to what? 2 pi. Okay, so you just substitute in your limit from this point onwards. You're going to have A over pi into minus out cos n pi, okay, minus, what is cos 0? Cos 0 is 1. Okay, here I can just bring A over pi out like this. And then what I can just do again is I can just write my minus here, okay, and then I can just bring my this thing here. Okay, so here I can have sorry, please see, I have minus minus here. Okay, I have minus minus here, so please, this place is going to be plus. Okay, so plus I can have here, so I have cos what? 2 pi n. Okay, oh sorry, I have to tell you something. Whenever you integrate cos nt, whenever you integrate sine nt, you get minus cos nt over n. So here also my over what? N. Okay, so I can bring what? N also out here like this. Okay, all right. So here cos 2 pi n. All right. Okay, so it's going to be and then minus this one. Okay, minus cos n pi. Okay, cos n pi. Okay, so this is what I'm going to have. Okay, all right. So now here, what I'm going to do here again is that I can have Bn is equals to A over n pi. Okay, into what I'm going to write here. Okay, here is just going to maintain. Okay, as minus cos n pi minus 1. Okay, all right. So let me, okay, plus here. So cos 2 pi n. What is the value for cos 2 pi n? Okay, so the value for cos 2 pi n will be always 1. Why do I say that the value for cos 2 pi n will always be 1? So let me just prove it to you. We are dealing with integers here. So this is the cosine graph. Okay, so here is what? 1. So here is minus 1. here is what? 0. So here, this place is what? Pi on 2. This place is what? Pi. This place is what? 3 pi on 2. This place is what? 2 pi. So here, you see that the value for what? 2 pi is what? 1. The value for 2 pi is 1. Okay. Now let's see something here. So even if n is 1, you still have what? 2 pi. And 2 pi is what? 1. Alright. If n is what? 2, you have what? 4 pi. And the value for what? 4 pi is what? 1. If n is 3, you have what? 6 pi. And the value for 6 pi is what? 1. Okay. If n is what? 4, you will have what? 8 pi. And the value for 8 pi is what? 1. If n is 5, you have what? 10 pi. The value for 10 pi is what? Also going to what? 1. So here I'm going to have 1 minus cos what? N pi. Okay, like this. Okay, so now here what I'm going to have is I'm going to have Bn is equals to wait, let me check some things if we did everything rightly. Alright, okay. I think things are quite alright. Okay, so here what we're going to have is A over N pi into, so here, this place, what I'm going to have is, if you multiply through by this minus 1, I'm going to have 1 minus cos N pi, okay, and then here plus 1 minus cos N pi, okay. So that is what I'm going to have at that particular point, okay, at that particular point, that's what I'm going to have, okay. So let us move on from here and then also see. Okay, so here you see that basically they are the same. So it's what? 2. So it's going to be what? If you add them, you're going to have 2a over what? N pi. Okay, you're going to have 2a over N pi into 1 minus cos N pi. Okay, so let's say n is equals to 1. If n is equals to 1, we're going to have what? If n is equals to 1, I'm going to have minus 1, okay, because it's the cosine waveform or the cosine signal. I'm going to have minus 1. Okay, so if you put minus 1 here, this place will go to, basically, if I put minus 1 here, okay, I'll have minus what? 1, which will be 2, okay. If n is equals to 2, then I'll have what? What is the cosine value for 2 pi? Then if n is 2, I'll have what? Cos 2 pi. Cos 2 pi is what? 1. Okay, so then it will what? 1 minus 1 is to go to 0. If n is 3, I'll have the cosine value for 3 pi is what? Is minus 1. So 1 minus 1, it will be 2. Okay, if n is equals to 4, the cosine value for cos 2 pi is 1. Then it will what? 1 minus 1 to go to what? 0. So n is equals to here it will be what? Odd. 3, 4, 8. 3. It will be n equal to what? 1, 3, 5, and then on and on and on. Okay, for this one. So in this case, so for so here I can say that n equals what? Odd numbers. Okay, n equals odd numbers. Okay, okay, and for n equals to these odd numbers, for n equals these odd numbers, okay, Bn will be equals to 2a over what? N pi, okay, into what? Into 2, because it always what? 1 minus 1 into 2, which is equal to what? 4a over what? N pi, okay. And then for n equals to even numbers, which is n equals 2, 4, 6, and on and on and on. Okay, for that one, okay, Bn is equals to what? 0. Alright. Okay. So this is how you can actually know it. Okay, sorry, when I was writing at that place it wasn't coming, but I'm sure now you can see it. Okay, so now that is your Bn. All right, so now let's realize our entire Fourier series equation. So from Fourier series, you know that f of t is equals to what? A naught plus what? Summation up to infinity, n is equals to what? 1. Okay, an cos what? Nt plus what? Bn sine what? Nt. Okay, here we found that a naught is equals to what? 0, and then an is also equals to what? 0. So our equation now becomes summation up to what? Infinity, n is equals to 1. Okay, bn sine what? N what? T. Okay, so this one is equals to what? What we find here. Okay, so what was our bn? Okay, we found our bn to be what? 4a over what? N pi. Okay, which is equals to what? 4a over what? N pi. Then you bring sine what? Nt. Sine Nt. Okay, so here f of what? T is equals to what? Summation up to infinity from what? 1. Okay, 4a over what? N pi into sine what? Nt. Okay, so now from here, what we can say is that f of what? T, we can bring 4a over pi out because it's a constant. So 4a over what? Pi out. Okay, and then n is equals to what? 1. And then I'll have what? 1 over what? N sine what? Nt. Okay, so here, let's say n is equals to 1. I'll have what? 1 over 1. So to what? Sine t. N is equals to 3. 1 over what? 3 sine what? T. So for the expansion, so this one is for this interval. So it's for the interval 0 to what? T to what? To 2 pi. Okay. Okay. So here for the expansion, okay, for the expansion, I'm going to have f of what? T is equals to what? 4a over what? Pi. For the expansion, I will not bring the summation again because I'm expanding. Okay, into what? If I put in 1 over 1 sine nt, so it will what? Sine it will what? Sine t, because if n is 1, here will become 1. So it will what? Sine t. If I put in what? 3 sine what? 1 over what? 3 sine what? 3t. If I put in, let me make it this way, plus what? If I put in 5, because it was defined for only what? Odd numbers, because the even numbers, you got 0. That's why I'm doing it for only what? Odd numbers. Okay, so 1 over what? 5, it will be what? Sine 5 what? T, and then plus, and then it goes on and on and on and on, up to infinity. I'm not doing it for the even numbers, because you realize that here we got the value for only what? Odd numbers. It was 0 for what? Even numbers. That's why here I'm doing it for what? Only even numbers. Okay, so basically this is how you can be able to solve this question. Thank you so much, and see you in the next class.